Hey guys, welcome back to Genius Learning. All right, in this video I want to show a very fundamental Physics 1 problem. All right, here we have a wedge highlighted in green, and we have a pulley, right, massless, we'll assume massless, and we have two masses, M1, M2, attached by a rope. Okay, we know that, or we're given that the acceleration is moving in this direction, going down, and we have an incline of 30 degrees. So what I like to do is always write down what's given first before starting. So we know the inclination of the wedge, we know the masses, and they also give us friction on this box, which is the only box that has or is touching a surface. So the friction for this box is 0.2. Okay, so two things. Okay, first, they gave us acceleration, but they don't tell us a coordinate system. The first thing you need to do is establish which way is positive and which way is negative. And that is usually up to you, unless it's specified in the problem. So none of this here was here. And so now I'm gonna impose the direction, positive and negative, whichever way I want it. So acceleration is going this way, and I'm gonna say that that's positive, it's in the positive direction. So the direction that they gave us initially. Against that motion is gonna be negative. All right, and so that means that here, right, my Y value, going down is positive, going up is negative. And for this box here, I have this direction here is the Y, which is perpendicular to the surface of the wedge. And then the direction that it's moving in is going to be positive X, negative X for the opposite direction. All right, so that's the first thing you're going to establish. Then we're going to solve this problem, and we need to find, I'm going to write that down. All right, find the tension. All right, the tension in the rope. So these two masses are going to be moving in one direction, right? And we want to know how much tension that's causing in this rope. And then we also want to know what the acceleration is because of that movement. How fast is this thing going to fall according to its mass and the degrees and the friction. So let's put all that into play here. So the first thing, let's take care of the free body diagram. So there's a free body diagram for mass 1, free body diagram for mass 2. So for mass 1, let's draw it out. All right, I'm just gonna draw the system in mass 1. So I got this triangle. I'm gonna put I'll just put degrees. I won't put how much right now. Okay, and then we got the box sits right up there. Okay, so I've shown this in another video, how to break up components, but I'll do it again. So the first thing you want to do is bring a line down, straight down from this box, right? And this is M1G. It's important to write the subscript, because then when we go to solve the equations later, we're gonna get confused if you don't. So MG is always in the downward direction, no matter even if it's slanted, right? That's the first thing we want to establish. Then what we want to do is identify the normal to the box, which is always perpendicular to its surface, the normal force. And that's the force that the wedge is pushing up on the box. All right, now the box pushing down on the wedge, we're going to draw this dotted line going this way. Okay, and we want to, this angle right here is going to be this angle in here, right? Because this is a right angle and this is a right angle. So a little bit of geometry here, but you can see that this big triangle is going to be the same thing as this little triangle in here now. So I'll just highlight this, and I have a video of this, one of the previous videos, so you can watch that. The trig is a little confusing. So because of that triangle now, I'm gonna say that adjacent, which is this one, over hypotenuse, which is this one, right? The 90 degrees, it's opposite. This is gonna be m1g cosine theta. Okay, and then now I'm gonna extend the line. So now let's extend the line and let's make it parallel to this line. So it's gonna be like this. See, this line here is parallel to this line here. All right, and then we're gonna draw another 90 degrees. And so now we can use this same triangle that we've used, but now it's a bigger triangle. And if you need a review on trig, I suggest watching the other video. It's purely this in a bigger form, and so it'll be a good review before doing something like this. So now we do opposite over hypotenuse, and we have m1g sine theta. All right, so we're gonna move, so this is a vector. We're gonna draw a little arrow there. We're gonna move this vector up here. Why would we do this? This box right here, if gravity is pushing straight down like this, and the wedge is sideways, gravity is now pushing the box this way. So instead of pushing the object straight down, because there's a wedge in the way, it pushes it down, but it's forced to the left, and this is the force of gravity. So that's how we identify that and label that. Okay, then we have the normal, and then what they're pushing back and forth on each other, and we need friction. So friction is always going to be opposing motion. So this box is going to move this way because the acceleration is that way. Friction is opposing the motion. So friction is always opposite to the motion, always, because it's slowing it down. It wants to stop the motion of the box, and so naturally it's going to be in the opposite direction. So we got that, we got this. So we need one more thing. Okay, let's do tension. So the tension is going to be in this direction, right? Same direction that is being pulled in. So we got everything for mass 1. Now let's do mass 2, which is a little bit easier. So let's just draw the box. And it's a little bit easier because we only have one coordinate to deal with, which is the y direction. This box only feels tension going up, and everything is subject to mg, mass times gravity. Just like we did this mass times gravity first, we're gonna do it here also. We're gonna do m2g. You see, this is very important to label because, like I said, if we start doing the equations and these are not labeled, you're gonna get it wrong. They're gonna be mixed up and they're different masses. So first thing you wanna do is mg, and then going up, which I should have done in red. Let's see. Let's do this. Is tension, because this box here is feeling tension from the rope going up, mg going down, and that's it. All right, so now we're looking a lot better to start solving the problem. We established a coordinate system, we got the free body diagrams. Now let's do the sum of forces. All right, so let's do for box and mass 1. All right, so sum of forces is going to be the sum of forces equals ma. Okay, and I'll explain what that means in a second. So the sum of forces means this thing has a force in the y direction, right? And it has a force in the x direction. So F, let's see, where do I write this? So F in the y direction, right? I'll just draw an arrow. I'm gonna put it here. So we're gonna have the normal force let's look at the free body diagram. All right, so we're gonna have in the y direction, which is upward, right here, we got y, and it's gonna be equal to this force going down because the box is not moving up and down as it goes. So the box is flat, meaning this force and this force are equal. That's why the box just goes straight and it doesn't like crush into the wedge, or it doesn't float off the wedge, because this force and this force are exactly equal. So in the y direction for box 1, we're gonna say that N is equal to M1G cosine theta. And before I confuse myself, let me highlight this. Much better. All right, now we do force in the x. All right, so force in the x for this box, now we're doing this and this, right? Because that's what we established as our x. So we want force and then equal ma. So what are the forces that are being applied to this box right here? Let's take a look. We did tension is going in this direction because of the rope, and that direction is positive. So tension is positive, right? We got gravitational forces pushing the box down and in this direction, which is in pink. So, and in this direction here is negative. So we got minus M1G sine theta, right? Because it's going in the negative direction. And we also have minus friction. So minus friction. All of that is equal to MA. And this is 1A. So we got M1A. Okay, let's see. All right, so we got that. And let's leave that there for a second. Okay, so now let's do box 2. And let's see, we got M2. Let's do the same thing. We're gonna find the sum of forces equal to MA. All right, so the sum of forces, let's do the sum of forces in the y direction for this box now. Up and down is the y, so going up is negative y, because that's what we established in the beginning with our acceleration, right? This way is positive, this way is negative. So going up is negative, meaning tension is negative. And then we have mg going down, which is positive. So positive M2G, right? And those are the only forces acting up on this box. So this is gonna equal M2A, because it's force, which is this whole thing right here. This is the force equal to MA. This is MA. And the M we're talking about is M2. This is the force, right, equal to MA. And this here also, just to note, because I know that I'm saying that this here is the force, this one, right, equal M1A, this is MA, so this is the general, and this one also is force, right, equals MA. This one here was the same thing, but we wrote it in this form, which is usually the way you need to use it. So we can also do force equals MA, but we're gonna do normal minus, because up is positive for the y, right? And then down is gonna be negative y. So minus M1G cosine theta equals, so this part here is the force acting on this box, and it's gonna equal MA, right? But there's no acceleration in the y. So this is 0. Because, like I said, this thing is not moving up and down like this. It's only moving horizontal. And so the acceleration is 0. And then we pass the m1g over to the other side and we get this equation here. Okay, so they're all like F equals ma, but this one we just skipped a step. All right, now we're gonna do fx, and that's gonna be 0. So there's nothing happening in the x direction. So literally you can just write 0, it doesn't matter. All right, so we have this going on for m1, this is going on for m2. Okay, let's see. Now we're gonna use this formula here, or this equation here, and solve for tension. Okay, so what do we need to find? Tension. We could either solve for this one here or this one here, and we're gonna find that in both cases we don't have acceleration. We don't have the value of acceleration. We have friction, which I'm about to show you the formula now. We have m1, we have g, we have theta, but we don't have acceleration. So let's solve this one for t. So let's see. So here, I'm gonna do from this one here, let's put it over here. We're gonna do t, we're gonna move the t to the other side, it's gonna be positive, and m2a is gonna go to this side, which makes it negative. So it's gonna be m2g minus m2a. So all I did was pass this m2a to the other side, which made it negative. And then I passed this negative tension to the other side, which made it positive. So here, we're gonna do t is equal to, we'll take out the m2, we got g minus a. So let's hold this equation here, right? And we're looking for acceleration, because that's what we're missing from this, to find tension. So hold that for a second, right? And now let's go over here and see how we solve for acceleration. All right, so let's see what color. Okay. So let's box this out. All right, so now we need to solve for A, right? Because with that, we will find acceleration and we'll find the tension. So we need to use F equals ma, but this time we're gonna use the force net is equal to mass total times acceleration. So what this means is all the forces that are acting on both of these boxes is gonna be on this side. And then both masses are gonna be represented by mt. So mass 1 plus mass 2, and then acceleration. So let's put both forces on this side. So for this one here, which is this box, in this direction, we have this whole thing as the force, right? And we need the net force. So let me write this out. We're gonna do F1 plus F2 equals M total A. So maybe that's a better visual. So both forces, we're gonna need this one here and this one here. All right, and this one's neutral because it doesn't move in the Y. So all the forces acting on it are these two right here. So let's put this right here, tension minus M1G sine theta minus friction. And then here we're gonna add it, so it's minus T, tension, plus M2G. So this whole thing right here is both forces together, and all of that is equal to M total, which is M1 plus M2 times acceleration. All right, now we see clearly that tensions cancel out, right? Because a negative and a positive. And we don't know what friction is yet. So let's deal with that. So for friction, so we'll put here, note, we're stopping this for a second. Friction is gonna equal the normal force times mu, which is the coefficient of friction, right? We know what the normal force is on this box because we found it right here. So we know what this is. So we got friction is equal to M1 G cosine theta times, so we'll put this in parentheses. This is for the normal times mu, and mu was given to us. So now we have this that we got to write here. So let's write that out one more time. We got this, let's see, we got negative, okay, so starting up again, we're gonna rewrite this, okay? So we got negative M1 G sine theta minus friction, which is this whole thing here. I'll keep it in pink. And then plus M2G. And I'm gonna divide the M1 plus M2 to this side. So everything here is gonna be divided by M1 plus M2. Everything is equal to A. So, perfect. Let me make sure. All right, so we have this cosine with the mu and positive, and these two are positive. So we have everything we need for acceleration, and we have all these values. So I'll write them in, but I do not want to use the calculator again. A lot of numbers. So I'm gonna just write all the values for everything. So A is equal to this thing. So minus, what's M1? We got 5. And I'm not gonna write the units. It's just probably confuse more, trying to solve this. So M1 is 5 kilograms. G is 9.8. Sine of 30 degrees minus, we have M1, which is 5, G, which is 9.8, cosine of 30, and degrees, and mu is 0.2, plus, let's see if I got space here. All right, so plus, we're gonna do M2, which is 6, times 9 point, let's see, we got 6 times gravity, which is 9.8. Okay, so let's see. All right, perfect. So that's the top part. Then everything is divided by M1 is 5 plus M2, which is 6. All right, so we put that in the calculator and we find that acceleration is 2.35, and the units for acceleration, which are very important, is meters per second squared. Okay, perfect. We found acceleration, so that's, let's see, make sure I got some room here. Let me push this up a little bit. Okay, we have acceleration, right, which is one of the answers. And now we can plug this acceleration into here and find out what our tension is. So tension is equal to M2, which is 6. Gravity is 9.8 minus 2.35, right? And I'm avoiding using the units just because, it'll take longer and it's It's a lot more confusing. So let me see. Okay, now we'll put that in the calculator, and we get tension is equal to 44.7 newtons, because tension, which is our force, is measured in newtons. So that's something you should know. If you're not going to write the units out and do the math for it, then know what the units should be at the end. And that's it. We found our tension. So quick recap. When you're given the initial problem, establish a coordinate system that you like, and then write out your given information and understand how to navigate, finding these two things. So tension, acceleration. The first thing you want to do, free body diagram. What are the forces being applied to this object by itself? What are the forces being applied to this object by itself? Now we can move on to sum of forces, which means the sum of forces, the force in the y and the force in the x. So it's not enough to say just the force, because now there's force being applied in two directions. So in the y direction, this thing is not moving up and down, so both of those forces are equal. In the x direction, we got tension going this way, we got friction opposing the motion, and we got gravitational force pushing the box down this way. And so F equals ma. We do the same thing for the other box. Fy is the only thing that has a force, and in the x direction for here we don't have any forces. So from this equation we solved for tension, and we found out that we're missing acceleration. So we go here, solve for acceleration, this time using our sum of forces equals ma, but for net, the net force of this entire system. And so that's both forces added up, and the only thing that has a force in the first box is in the horizontal direction, and the second one in the vertical direction. So you add these up, tension cancels out, and we use the formula for friction, which is normal times mu. We know the normal because we found it here, all right, times mu, which is given to us, and we add that into the equation. So now we have just this times friction plus m2g equals, and we divide the both masses to the other side, single out acceleration, which is what we're looking for, right? Plug all this in, and acceleration is 2.35. We found that. Now we plug this into the equation that we were holding on to before, and we solve for tension. All right, and that's it. All right, hopefully it was helpful. Make sure you guys subscribe and comment below. Thank you guys.